Assalamu alaikum. Hi, students and friends. This is your host and teacher Sayyid Ayazuddin Haider. You're watching Learn and Teach by Sir Ayaz. So I'm continuing my past paper sessions, and this time I've selected O levels 5070. Variant is 22, and it's of October, November 2024. You know the total time. It's 1 hour 45 minutes. It's paper 2 theory. You have to answer all the questions. You can use calculator. The total mark for this paper is 80. Your table is printed on in the question paper. So let's start the paper. Here's question number 1. Part A. Figure 1.1 shows the electronic configurations of 5 atoms A, B, C, D, and E. It's figure 1.1. Answer the questions about these electronic configurations. Each electronic configuration may be used once, more than once, or not at all. State which electronic configuration A, B, C, D, or E represents. Number 1, an atom of a noble gas. Now here we are having group 8 element. These are noble gases. We have helium, neon, argon, krypton, xenon, radon, and organoson. What's so special about group 8 elements is that their valence shell is complete. That is, they all have 8 valence electrons except helium. Helium have only 2 valence electrons. So let's look at the valence shell of all of these A, B, C, D, E. In A, we have 2 valence electrons. It's not possible. The reason is that it's 1, 2, 3, 4, fourth shell. You can't have 2 valence electrons in the fourth shell. There must be 8 valence electrons. First shell is the only which can occupy maximum of 2 valence electrons. What about B? There are 8 valence electrons in the second shell. This looks correct to me. If you look at the other choices, in C you have 6, in D we have 5, and E we are having 3 valence electrons. So B must be the right answer for part 1. Number 2, an atom of an element that is used in food containers because of its resistance to corrosion. If you look at the periodic table, here's aluminum. Aluminum is used in food containers because it forms protective oxide layer which prevents its further reaction. So aluminum, the proton number of aluminum, it's 13, which means it has 3 valence electrons. So if you look at the position of aluminum, it's in period 3. It's in period 3, which means it must have 3 shells and there must be 3 valence electrons in the third shell. In A, we are having 4 shells, so it can't be the right answer. B, it's 2 shells. B, C, D, all these 3 have 2 shells. E seems to be the correct answer because there are 3 shells and there's also 3 valence electrons in E. C, 1, 2, 3. So E must be the right answer for part 2. Number 3, an atom of an element in group 5 of the periodic table. In order for an element in group 5, it must have 5 valence electrons. So straight away, you will look at the number of valence electrons in all of these. In A, we have 2 valence electrons, B, 8, C, 6, D, 5. So it must be D because it contains 5 valence electrons. 5 valence electrons. Number 4, an atom of an element in period 3 of the periodic table. So this atom must be in the period 3 of the periodic table. So logic is very simple. It must be having 3 shells in all. So if you look at these letters again, so E must be the right answer in this case because E is the only atom which contains 3 shells. So it must be in the period 3 of the periodic table. So number 4, it's E. What about number 5? An atom that forms a stable ion with a charge of 2 minus. Here is a periodic table. If you look at the groups, 2 minus means this atom is gaining 2 electrons. So group 6 is the one which need 2 electrons to complete its valence shell to form -2 charge ion. And for this, they must have 6 valence electrons. And if you look at these letters, C is the only atom which has 6 valence electrons. So C must be the right answer in this case. B, deduce the number of protons and neutrons in the vanadium atom shown. V 23, 51. 23 represents the number of protons, so you will straight away write 23 here. What about number of neutrons? In order to get the number of neutrons, you have to subtract the proton number from nucleon number. Nucleon number is 51, which is provided. So you'll subtract 23 from 51. 51 minus 23. And the answer is 28. So 28 is the number of neutrons in this case. Number 2, iron is extracted in the blast furnace by the reduction of iron 3 oxide Fe2O3. This process is made up of 3 steps. A1. In step 1, carbon burns in air to produce carbon dioxide. Give one other reason why carbon is burned in air in the blast furnace. Definitely to heat the furnace because the melting point of iron 3 oxide is very high. So we need high temperature in order to melt it down. So what I will write? I will write to heat the furnace. Number 2, in step 2, carbon monoxide is produced by the reaction of carbon dioxide with carbon. State 1, adverse effect of carbon monoxide on health. Carbon monoxide is toxic or poisonous gas because it reacts irreversibly with the hemoglobin in our body. In this way, it blocks the transport of oxygen to different parts of the body. So we will write toxic or poisonous. Toxic or poisonous. Number 3, in step 3, iron 3 oxide is reduced by carbon monoxide. Write the symbol equation for this reaction. Now we have to write the reaction equation between iron 3 oxide and carbon monoxide. The formula of iron 3 oxide is given, it's Fe2O3. Carbon monoxide is CO. It's the reducing agent in the blast furnace and it will convert this iron 3 oxide into iron and the other product produces carbon dioxide. Let's balance the reaction equation. In order to balance the oxygen, we will place 3 before CO and then 3 before CO2. For Fe, I will write 2. No, all of these are balanced now. B, explain why calcium carbonate is added to the blast furnace. Include any relevant reactions or equations in your answer. So you have to give a reaction equation also and it's of 2 marks. So first of all, calcium carbonate decomposes to produce calcium oxide. And this calcium oxide reacts with impurities, which is sand or silicon 4 oxide. So I will write calcium carbonate decomposes to produce calcium oxide, CaCO3 will produce CaO plus CO2. And this calcium oxide, CaO, calcium oxide, you can write reacts with impurities. You can mention the impurities, that is sand or silicon 4 oxide. Reacts with sand, silicon 4 oxide. Now write down the reaction equation, which is CaO plus SiO2 gives CaSiO3. See, iron is a transition element. Transition elements have high melting and boiling points. State two other properties that are typical of transition elements but not of group 1 metals. Here's a group 1. In group 1, we are having lithium, sodium, potassium, rubidium, cesium, francium. And here we are having transition elements or metals. Transition elements or metals. Here's iron. Now what they are saying, you have to state two properties. They are saying properties. They didn't mention chemical or physical properties, so you can include any two other properties that are typical of transition elements but not of group 1 metals. Group 1 metals, we know that they are soft, they have low density, they have low melting point, they do not form any colored compounds, they don't have any variable oxidation numbers, and they do not act as catalyst. So they have already mentioned one of the property, that is melting and boiling point. Group 1 metals, they have low melting and boiling point. So I'm not going to refer to the melting and boiling point. You can refer other properties. So you can write any two from these. Any two from hard, high density, form colored compounds, variable oxidation numbers, act as catalyst. Part D. Iron is prevented from rusting by galvanizing with zinc. Explain two different ways in which zinc prevents rusting. Now they are saying two different ways and it's of 3 marks. So I think there must be a mistake here. They must be asking 3 different ways, not 2 different ways, because it's of 3 marks. So definitely we'll have 3 statements for this. Any 3 from. So if you look at the marking scheme, they gave 3 statements. correct statements. You have to write any three from these. So what are these statements? That zinc, it's forming a protective layer, and in this way it prevents oxygen or water reaching the surface of iron. You can even refer to the reactivity of zinc comparing with iron. Like zinc is more reactive than iron, or you can write zinc reacts or corrodes in preference to iron. So I will write zinc forms a protective oxide layer. Zinc prevents oxygen or water reaching the surface of iron. Or you can even refer reactivity or compare reactivity of zinc with iron. Like you can write Zn, that is zinc more reactive than iron, or zinc corrodes in preference to iron. E. The equation shows the reaction of iron with steam in a closed container. Here is the reaction equation: 3FeS plus 4H2OG, reversible sign, Fe3O4S plus 4H2G. Predict and explain what happens to the position of equilibrium when the pressure is increased. The temperature remains the same. Now they are asking what happens to the position of equilibrium when the pressure is increased and the temperature remains the same. Now the effect of pressure is that if you increase the pressure, the volume of the gas will decrease. The effect of pressure is only applicable to gases. So you look at the total number of moles, molecules, or volume of gases on both sides of the equation. So if you look at this equation, we have moles, molecules of gases. So on the reactant side, we have 4. But what the product side, again, we are having 4. So the prediction must be no effect. And for the explanation, refer moles or molecule of gases. Refer moles, molecules, or volumes of gases. That is same number of moles of gases on both sides of the equation. Fe3O4 reacts with concentrated hydrochloric acid. The products are iron 2 chloride, iron 3 chloride, and a liquid that turns blue, cobalt 2 chloride, paper pink. Construct the symbol equation for this reaction. Now, is the reaction between Fe3O4? They are not asking about the state symbol, so simply write down the reactants and products. It's reacted with concentrated hydrochloric acid. The products are iron 2 chloride. Iron 2 chloride means iron is having +2 as its valency or oxidation number. What about chlorine? Chlorine, it's in group 7. Oxidation number of chlorine or valency is -1. So I will write -1 here. Ignore the charges. Now swap these numbers. So we'll get FeCl2. What the other product? It's iron 3 chloride. In the same way, you can predict the formula for iron 3 chloride +3 -1. Ignore the charges. Swap these numbers. FeCl3. And then you are getting a liquid that turns blue cobalt 2 chloride paper pink. It's actually anhydrous. Blue cobalt 2 chloride paper anhydrous means it's without water, and when water become connected chemically, it will turn it into pink. So that water, that liquid is water. So I will write H2OL. Now let's balance the equation. Now if I will place 3 before FeCl2, sorry, 2 before FeCl2, iron become balanced. But what about the chlorine? 2 2s are 4, 4 plus 3 is 7. So I need to put 7 before HCl in order to balance chlorine, which seems impossible because you can't have 3.5 moles of H2 on the right hand side, which is like an infraction. You can't have the moles in fraction on the right hand side. So I will erase this. Now what if I will place 2 before FeCl3? Iron is balanced? No, iron is balanced. What about Cl? 2 3s are 6, 6 plus 2 is 8. This looks possible if I will place 8 before HCl and 4 before H2O. No, this looks correct to me. So I will write 8 here, 2 here, and 4 here. This is balanced now. If you count the number of atoms, all balanced. 3 Fe on both sides of the equation, oxygen 4 on both sides, hydrogen 8, chlorine 8. On the right hand side, you have 2 plus 6, 8. Moving to next question, which is question number 3. Figure 3.1 shows the apparatus used for the electrolysis of dilute sulfuric acid using graphite electrodes. So here's the diagram, which is figure 3.1 with power supply and electrodes and 2 inverted test tubes for the collection of products. A, define the term electrolysis. Now the term electrolysis, we have electro and then you are having lysis. Lysis means breakdown. Electro means current, passage of current. Now, so the meaning of the term electrolysis is that it's a breakdown or decomposition. Breakdown or decomposition of ionic substance. Breakdown or decomposition of ionic substance by passage of current. In molten or aqueous state. B. Label the anode on figure 3.1. On figure 3.1, we have to label the anode. So anode must be the one which is carrying the positive charge. So on the left hand side, you will label it as anode. This one is anode. C1, name the product at the cathode. You have the electrolysis of dilute sulfuric acid. So at the cathode, you are getting hydrogen gas. And at the anode, you will get oxygen gas and water. And the question they are asking, name the product at the cathode, which is hydrogen gas. So I will write hydrogen gas. Number 2, oxygen is formed at the anode. I've already mentioned. Construct the ionic half equation for the reaction at the anode. And you are having hydroxide ion moving towards anode, producing oxygen gas. Water is also produced. H2O liquid plus electrons are produced. Let's balance the equation. The 4OH negative, 2 moles of H2O and 4 moles of electrons. This will be the final balanced final equation. D. Name a suitable element other than graphite that is used for the electrodes in this electrolysis. So definitely will go for the substance that must be having high melting point. It's inert and or unreactive. It's none other than platinum. So I will write platinum. Number 4. This question is about alkanes and alkenes. A. Butane belongs to the alkane homologous series. Members of the same homologous series have the same functional group and the same general formula. State 2 other characteristics of homologous series. Now you can refer to the difference of CH2 between different members and or trend in physical properties, or talk about chemical properties, or talk about same method of preparation. So you can write any two from these. Any two from. Members differ by CH2 group. The trend in physical properties similar chemical properties or even same method of preparation. You can write any two from these. Part B. Figure 4.1 shows the displayed formula of butane. Here's figure 4.1 showing the displayed formula of butane. Number 1, explain how figure 4.1 shows that butane is a saturated compound. Definitely having all the carbon-carbon bonds are single. All the carbon bonds are single. Number 2, give the structure formula of butane. Now they are asking about structure formula. Structure formula is also known as condensed formula. In which we are going to show the condensed form. So I will write CH3. Then we have CH2, CH2. Again, you are having CH3. So this will be the structure formula of butane. C, nonane C9H20 is present in the naphtha fraction. from the distillation of petroleum. Number one, state one use of the naphtha fraction. Now, naphtha fraction is used to make other products, and the term used for this purpose is chemical feedstock. So you write chemical feedstock because it's used for the preparation of many other products. That's why you will call it chemical feedstock. Number two, when nonane is cracked, shorter hydrocarbon molecules are formed. Construct the symbol equation for a reaction in which nonane is cracked and the only products are propane and ethene. So the formula of nonane is given, which is C9H20, and they said the only products are propane. Propane means 3 carbon and it belongs to alkane family. You know the alkane family, the general formula for alkane family is CnH2n plus 2. So n is 3 here. So you'll have 3 multiplied by 2 6, 6 plus 2 is 8, H8 plus. Second is ethene, which is alkene. General formula is CnH2n. In fact, it's the first member, so n is 2 here. So you write 2, C2, H, 2 multiplied by 2 is 4, H4. Now this reaction is not balanced. So what if I will place 2 before propane? So 2 multiplied by 3 is 6. 6 plus 2, 8. This is incorrect. What if I will place 3 before propane? So if I write 3, 3 3s are 9. This is also incorrect because then you can't have the other product in this case. So you can't write any number before propane. What about ethene? What if I will place 2 before ethene? 2 to the 4, 4 plus 3, 7. The carbon atoms become 7. Again, the carbon is not balanced. So now if I will place 3 before ethene, so we'll have 3C2H4. 3 to the 6, 6 plus 3 is 9. Now carbon is balanced. What about hydrogen now? 3 4s are 12. 12 plus 8 is 20. It means we have to place 3 here. This is balanced now. D. Propane reacts with chlorine in the presence of ultraviolet light. Figure 4.2 shows the displayed formula of the reactants and products. Here we have reactants and products. Number 1. Name the type of chemical reaction that takes place. Now this reaction involves the substitution of hydrogen by chlorine atom. One of the hydrogen gets substituted by one chlorine at a time in this reaction. So you write substitution reaction, substitution. Part 2, state the purpose of the ultraviolet light in this reaction. It's providing the activation energy for the reaction. So you write provides the activation energy for the reaction. Part 3, calculate the enthalpy change for this reaction in kilojoule per mole. Use the bond energies in table 4.1. Here's table 4.1. We need to calculate the enthalpy change. Now what I am going to do, I will write down the reaction here. First of all, here's the reaction. We have 1, 2, 3. So Cl, Cl, and we are getting 1, 2, 3. Well, HCl. These are hydrogen. No need to scroll this. So we need to calculate the enthalpy change. You know the formula for enthalpy change. The formula is energy needed to break bond minus energy released to make bond. So we are having one of the bond CH, it's broken. So this bond is broken, and there is breakdown of this Cl bond also. So CH bond we have 413. We have only one CH bond, so I will write 413. And Cl bond Cl, we have one Cl bond, so you'll write 243. Now, what bonds are made here? CCl bond is made here, you can see here, and HCl bond is also made here. So CCl bond, we have 346 plus HCl bond, 1 mole of HCl bond, so you'll write 432. So minus, so 413 plus 243. 413 plus 243. 656 minus 346 plus 432. We're getting 778. So 656 minus 778 minus 122. Minus 122 kilojoule per mole. This will be the final answer. Part E, the equation shows the reaction of ethene with chlorine. C2H4 plus Cl2 gives C2H4 Cl2. Explain how this equation shows that this reaction is an addition reaction. Only a single product is formed. Only a single product is formed. Question number 5. A student adds large pieces of zinc to dilute hydrochloric acid. The zinc is in excess. A. Complete the equation by adding state symbols for the products. Zn solid plus 2HCl aqueous gives ZnCl2. All chlorides are soluble except lead, mercury, silver. Zinc chloride is soluble, so you'll write aqueous for zinc chloride ZnCl2. So I'll write AQ here. But what H2 exists in the gas state, so I'll write G for H2. B. Figure 5.1 shows how the volume of hydrogen changes with time as the reaction proceeds. Number 1, describe how the shape of the curve in figure 5.1 shows that the rate of reaction decreases with time. If you look at this graph, you can see the gradient decreases as time increases. So you write the gradient decreases as time increases. Number 2, explain in terms of collision theory Why the rate of reaction decreases with time? You see, you have as time progresses, the number of particles decreases and the particles also getting further apart. So the frequency of collision between these particles also decreases. So we will write particles get further apart. Particles get further apart. Frequency of collisions of the particles decreases. Number 3, the student repeats the experiment using the same mass of powdered zinc instead of large pieces of zinc. All other conditions stay the same. Describe and explain the difference in the rate of reaction when powdered zinc is used. So definitely rate will increase because powders have greater surface area and the collision frequency also increases. But you can even say there will be more collision per unit time. So I will write rate increases. Rate increases because powdered form have greater surface area, which means you have more collisions per unit time. Can even write collision frequency increases. C. Excess zinc is added to 16 centimeter cube of 0.4 mole per dm cube hydrochloric acid. Calculate the volume of hydrogen gas released measured at room temperature and pressure. Give your answer to two significant figures. Now, according to this reaction equation, we have 2 moles of hydrochloric acid and 1 mole of hydrogen gas produced. So, for your convenience, I am writing the reaction here. Reactant, that is 2HCl, giving 1 mole of H2 gas. Now, first of all, I am going to calculate the moles of hydrochloric acid. Moles of HCl. So, 0.4 mole per dm cube means there will be 0.4 moles in 1000 centimeter cube. 1000 centimeter cube contains 0.4 moles. Therefore, 16 centimeter cube contains X moles. Do the cross. So X is equal to 0.4 multiplied by 16 divided by 1000. Sixteen multiplied by 0.4 divided by 1000. So 0.0064 moles. These are the moles of hydrochloric acid according to the relation We have HCl and H2 here, 2 moles producing 1 mole. Therefore, 0.0064 moles produces X mole. Do the cross, it will become X is equal to 0.0064 divided by 2, which becomes 0.0032 moles. 0.0032 moles. Now, in order to get the volume of H2, they have mentioned at room temperature pressure. We know that 1 mole of a gas at RTP. RTP is room temperature pressure, occupies a volume of 24 dm cube. So you need to multiply these moles by 24.0032 multiply by 24. So the answer becomes 0.0768. 0.0768, or you can even write 0.077 dm cube. This will be the final answer. Moving to next part, which is part D. The reaction of zinc with hydrochloric acid is exothermic. Complete the reaction pathway diagram in figure 5.2 to show the reactants and products. A labeled arrow for the activation energy EA, a labeled arrow for the enthalpy change delta H. Remember, for the exothermic reaction, reactants at high energy state than products, which means in case of endothermic reaction, you have reactants will be at lower energy state than the products. So I will make a line here like this for the reactants, and for the product we have a line on the right hand side like this. In between these two will be having energy hump. This is energy hump for the activation energy. This is activation energy. It's going up. Remember, activation energy, the arrow must be going up. And as the energy is released, exothermic means energy is released to the surrounding, and product is at the low energy state. So the energy difference between the reactant and product must be shown in this way. Change in energy between reactant and product. Another thing, you have to write the reactants and products. So reactants, we have Zn2HCl, ZnCl2H2. Zn plus 2HCl, and we'll be getting ZnCl2 plus H2. Let's label it. We have EA for the activation energy and delta H for the enthalpy change. So this will be the final label diagram for this reaction. Part E, describe the observations made when a few drops of aqueous ammonia are added to an aqueous solution containing zinc ions. Now, zinc ions in aqueous ammonia gives white precipitate. So I will write down white precipitates. And in excess aqueous ammonia, When excess aqueous ammonia is added to an aqueous solution containing zinc ions, what will happen? It will dissolve or soluble to form colorless solution. Soluble or dissolves to form colorless solution. Next part, which is F, describe how to prepare pure dry crystals of zinc chloride after reacting excess zinc with dilute hydrochloric acid. So you have 3 marks for this. So you can write any 4 statements, any 4 from. Definitely you have excess of zinc in hydrochloric acid, so you have to remove excess or unreacted zinc. So first of all, you need to filter. Next point, wash the residue with distilled water. Wash the residue with distilled water. Then we evaporate through gentle heating. So that you will cool down or crystallize. Then you dry the crystals. Remember, for evaporation, you will evaporate the filtrate. You have to mention evaporate the filtrate. This point is very important. You have to write filter. You have to start with the filter because there is excess zinc. So then you have any 3 points from other 4. Question number 6. Figure 6.1 shows the structures of boron nitride and hydrazine. Boron nitride has a structure similar to diamond. You see the structure of boron nitride, it's like diamond. Diamond also have a structure like this. The only difference is that diamond, it's a allotrope of carbon, while boron nitride is a compound. It's not an element. So A, explain why boron nitride has a high melting point. Use the information in figure 6.1. So in the 6.1, they have already mentioned the structure resembles diamond. So you will start with this statement, giant structure and having many or strong covalent bonds. Giant structure with many or strong covalent bonds. B, explain why hydrazine is a poor electrical conductor. Use the information in figure 6.1. See the figure 6.1, you have hydrazine here. If you look at this structure, it's definitely containing covalent bond and the structure indicates that it's a simple molecule. So it must not have any mobile electrons. So you write mobile electrons are absent. Mobile electrons are absent. C, Complete figure 6.2 to show the dot and cross diagram for the electronic configuration of hydrazine. Show only the outer shell electrons. Now what I'm going to do, I'm going to show the key on the right hand side, which will help you to place the electrons, valence electrons for each of these, nitrogen and hydrogen. For nitrogen, I'm using cross. For hydrogen, I'm using dot. If you look at the position of nitrogen, his nitrogen is in group 5, which means it contains 5 valence electrons. Each of nitrogen atom having 5 valence electrons, while hydrogen, they have 1 valence electron. The proton number of hydrogen is 1. So each hydrogen atom, they are having 1 valence electron. So for the right hand side, 1 for this hydrogen, 1 for this hydrogen, 1 for this hydrogen. Now, for nitrogen, each nitrogen, we have to show 5 valence electrons. So 1, 2, 3, 4, 5. For left hand side, 1, 2, 3, 4, 5. So if you count the total number of electrons in each of these circles, for each nitrogen, it should be 8. 1, 2, 3, 4, 5, 6, 7, 8. For the left hand side, 1, 2, 3, 4, 5, 6, 7, 8. And for each hydrogen atom, there will be 2 electrons. Moving to next part. This is part B. The ionic equation for the reaction of nitride ions with water is shown. Here is the reaction N3 minus plus 3H2O N3 minus plus 3H2O give NH plus 3OH minus. Number 1, the oxidation number of hydrogen in NH3 is plus. The oxidation number of nitrogen in NH3. Whenever hydrogen is non-metal, it must be having X plus equal to. So it must be minus 3. Not a redox reaction by referring to the oxidation number of nitrogen. Look at the oxidation number of nitrogen. It's minus 3 here or 3 minus here. So it's not a redox reaction. So it does not change or remain same. Per of and does not change or remain same. That is minus 3. Party. Boron oxide reacts with magnesium as shown. Reaction equation B2O3 plus 3Mg gives 2B plus 3MgO. 8 gram of boron oxide is reacted with 7.2 gram of magnesium. Show by calculation that boron oxide is in excess. Now you have two options, either convert mass into moles or use these mass in order to find out or prove that boron oxide is in excess. So I will going to write here either convert gram into moles or use the mass given, or use the mass given. Now for the moles, what I will do, if I want to find moles of B2O3, I need to divide 8 by MR of B2O3. So MR of B2O3. Here is B, 11 is the AR, oxygen 16. So 11 multiplied by 2, 16 multiplied by 3. So we have 22 plus 48. If you will add up these, what you will get? 8, 9, 10, 0, 1, 4, 5, 6, 7. 70. 8 divided by 70. MR will be 74 B2O3. 8 divided by 70, it becomes 0.114. These are the moles of B2O3. What about the moles of Mg? We have 7.2 grams. So now in this case, we need AR of Mg. Here is Mg. It's 24. So you divide it by 10. Becomes 0.3. 0.3 moles of Mg. Now start comparing. Right in the reaction, B2O3 plus 3 Mg, which means 1 mole reacting with 3 moles of Mg. 1 mole reacts 3 mole of Mg. Therefore, 0.114 mole reacts with X mole of Mg. Do the cross, becomes X equal to 0.114 divided by 3. Sorry, 3 multiplied by 114. 3 multiplied by 0.114. And the answer will be 0.342 moles of Mg. Now compare these moles with the moles of magnesium. Here the requirement is high, so we have magnesium as limiting reactant, or B2O3 is in excess, boron oxide is in excess. So you write hence proved that boron oxide is in excess. Number 7, esters are represented by the formula CnH2 and O2. A1, state the name given to a formula such as CnH2 and O2. This is known as general formula. So you write general formula. Number 2, reduce the value of N in the ester propyl ethanoate. So propyl contains 3 carbon, ethanoate contains 2 carbons. 3 plus 2, 5. B, the ester ethyl butanoate is produced by reacting ethanol with butanoic acid. Draw the displayed formula of ethyl butanoate. So we have ethyl coming from ethanol. So ethyl group must be this 1, 2, and it's attached to butanoate through this ester linkage. We have oxygen, bond carbon, double bond O. Then we must be having 3 more carbons. 1, 2, 3. So this is the displayed formula for ethyl butanoate. C. Figure 7.1 shows the simplified structures of two molecules that combine to form a polyester. The top one must be diol. There are two OH group, and second one must be dicarboxylic acid. There are C double OH group on both the ends. Figure 7.1. Number 1, complete the diagram in figure 7.2 to show the structure of two repeat units of this polyester. Show all of the atoms on all of the bonds in the linkages. Now, these will combine through condensation polymerization, and during condensation polymerization, there will be loss of OH from these diol and H from these alcohol. You can even remove OH from these dicarboxylic acid, then you have to remove H from diols. And this results loss of 2 moles of water molecule. Now I'm showing the linkage between these. So this one must be coming from diol. It will be joined through O bond C double bond O with this dicarboxylic acid. From the other end, we have again C double bond O, then O again attached to this blank box. Then we are again having O, C double bond O, C double bond O, O on this end, so on. This will be the final repeat units. Number 2, name the type of polymerization in this reaction. It's condensation. So I will write condensation here. D. PET is a plastic. Describe the chemical processes involved in converting used PET into a new plastic. Now we want to convert the used PET into a new plastic. So simply you have to break it down into its monomers. So PET broken down into monomers. Then monomers repolymerized. Monomers repolymerized. In this way, you can convert this into new plastic. Party ethanoic acid reacts with sodium carbonate. Number 1, name the 3 products of this reaction. This reaction between acid and metal carbonate. So whenever you react acid with metal carbonate, you will get 3 products: salt, carbon dioxide, and water. In this case, the salt must be sodium ethanoate. So you write sodium ethanoate as one of the product. So other the 2 products will be water and carbon dioxide. Part 2, ethanoic acid is a liquid at room temperature. Describe the arrangement and motion of the particles in a liquid. Simply in liquid, we know that the arrangement is loosely packed. Loosely packed, which means it's irregular or irregular. What about the motion? They are changing places, sliding over each other. Changing places or sliding over each other. Thanks for watching. Press like and share my videos. For more videos, subscribe to my channel and press the bell icon.